Okay. So next one is the homologous series. The homologous series is a group of the carbon compounds having a similar structures, similar chemical properties, and whose successive members differ by the CH2 group. So that we call it as a homologous series. Example, alkanes, alkenes, alkanes. So for example, the first we are going to see about the alkanes. So the alkenes are having the formula CnH2n. So this is the general formula for the alkenes. And we know that ANE indicates that it's a alkane family. Okay. So now in this case, we are going to substitute the N equal to 1. So in this formula, CnH2n plus 2, we are going to substitute N equal to 1. So we will get this CH4. This is the first member of the family, methane. Then we are going to substitute N equal to 2 in this formula. So we will get C2H6. We call it as ethane, the second member of the family. This is N equal to 3. We are substitute over here in this formula. So C3H8. So 3 we are substituting. So 3 times 2 is 6 plus 2, 8. So C3H8. So the butane N equal to 4. So C4H10. This is N equal to 5. So C5H12. So like this, we are having a C1 to C70 alkanes, C70 carbon atoms present. So if we know this formula, we can able to write the any hydrocarbon formula. For example, suppose I would like to write the C10 carbon atom, so which is a alkane. I would like to write the molecular formula for this. So N equal to 10. I'm going to substitute in this formula. So C10H, so 2 times 10 plus 2. So which is nothing but C10H22. So this is the C10 formula. Okay. Yeah. So this is the one. So all these are having the same molecular formula CnH2n plus 2. So that's why we call it as a homologous series. Homologous series means it's having a similar structure and it's having the same chemical properties. So chemical properties in the sense, so all the methane, ethane, propane, butane, pentane, everything we are using it for the burning purposes. So the methane, we know that it is a natural gas, and the propane and the butane we are using in the LPG. In the day-to-day life, we are using the cylinders which is used for our cooking. So the LPG, the cylinders contains the liquefied propane and the butane. So the pentane and the hexane are nothing but the petrol. So like this, we are having a diesel, kerosene. So everything is a alkanes, which is a saturated hydrocarbons, which we are using it in our day-to-day life. So all the alkanes family, we are using it for the burning purposes. And also, what is that the whose successive members differ by the CH2 group? What is meaning? So here we are going to take the methane and the ethane. So what is the difference between these two group? So one is the CH4, another one is the C2H6. What is the difference? So C and H6 and H4, so H2. So this is the difference. This difference you can see all over the C70 carbon atoms. So this difference is also CH2. This difference is CH2. So all the successive members is having a difference of CH2. So that we call it, that is the one of the important property in the homologous series whose successive members differ by the CH2 group. So alkanes are the homologous series. So methane is having the formula CH4. The carbon is making a 4 bonds with the 4 different hydrogen atoms. Ethane, ethane is having the formula C2H6. So we have to write the C single bond C and has to make the 6 hydrogen atoms according to the 4 bonds of the carbon atoms. Propane C3H8. So we have to write the C single bond, C carbon atoms in the straight chain, and the remaining atoms we have to substitute over here. The next member is the alkenes. So alkenes are having the general formula CnH2n. Okay. So their names always ends with the "ene." So this is also the member of the homologous series. This also have the same characteristics. It's having the same all the members of the family has the same general formula, same chemical properties, and also the successive members differ by the CH2 group. Okay, so now we are going to see that one. So now if we are going to substitute N equal to 2. So in this formula CnH2n, so we will be getting the C2H2 times 2. So C2H4. So this propene will get N equal to 3. So if you substitute, so C3H2 times of 3. So we will get the C3H6. And the next one is the butene. So N equal to 4. So C4H2 times of 4. So we are going to substitute in this molecular formula. So pentane is C5H10. Suppose if you would like to write the C8. So what is the formula for the C8 in the particular alkene means? So we can able to write N equal to 8. So C8H2 times of 8. So C8H16. So this is the formula for the C8 which is in the alkene family. So like this. So there is a no more the one we have to start from only the N equal to 2 because the alkenes are having the double bonds. So the double bonds it needs at least the 2 carbon atoms to make the double bond. So but the N equal to 1 means it has only 1 carbon atom. So we cannot able to there is a no more formula exist in the N equal to 1. So you have to start from N equal to 2. Okay. So now C2H4. So now here C double bond C and here it is a hydrogen we are going to substitute over here. So now in this carbon atom 1, 2, 3, 4. 4 bonds we have substituted in this carbon atom 1, 2, 3, 4. 4 carbon atoms substituted. So the tetravalent is completed over here. Propene. Yeah. So C single bond actually we have to write like this first. Then we have to write either the double bond here or here. That is your choice. But we have to write only one double bond in the one compound structure. We should not write the two double bonds. So if you are placing the double bond here, we have to make sure that the carbon atoms balancing. So this carbon is already having the two bonds here, one bond with the hydrogen atom like this. So this carbon atom is having 1, 2, 3. Already the 3 bonds are over. The other bond we have to satisfy with the hydrogen atom. So this carbon atom is having the 1 bond here, 3 bonds with the other hydrogen atoms. So we have to be very very careful while placing the hydrogen atoms and also damn sure that the carbon atoms having only 4 bonds at a time. That we have to confirm. Butene. Butene formula is C4H8. So the carbon C4 means 1, 2, 3, 4. The 4 carbon atoms we have to write it in a straight chain. The double bond we have to write over here. Now this carbon is having the 2 bonds here. Third bond with one hydrogen, fourth bond with this hydrogen. So we should not write one more over here. If you're writing like this, then it becomes carbon is having the 5 bonds. That should not happen. Then this carbon atom, 1, 2, 3. So 3 bonds already over the 1 bond with the hydrogen atom. Again, this carbon atom is having a single bond, 2 bonds here, 1 hydrogen above and below. This carbon atom is making a single bond with over here, 1, 2, 3. So 3 hydrogen atoms.